PyWake has been updated and upgraded and improved to become Dynamiks. Dynamiks is more accurate and it has more involved calculation, although the time spent is not as high as many other softwares, but it is more efficient than PyWake itself. So there is a presentation online which was done by Mans M. Pedersen. I have provided a link in the description for where you can actually download this presentation. The presentation being done here has been slightly modified than what Pedersen actually did, which is available online and is downloadable. So as we have an understanding of PyWake in the past, PyWake can be used for effective wind speed and including the wakes. It models it, it simulates it, then you can actually assess the power, annual energy production of wind farm, flow maps, analytical gradients, and it's also fast compared to most other software tools in the market. It's open source as well, so you see a free tool that is quick in order to run an analysis. Those are some benefits of PyWake. But then you now have Dynamiks. Dynamiks is a little more improved than PyWake. Dynamiks looks at calculations in time series, so it doesn't just give you a calculation at one point in space. Dynamics gives you calculations based on multiple reference times. For example, it could give you values at 2.5 seconds, at 10 seconds. It can give you at different points in time. And where there is convergence and for other reasons, this information is summarized and voted for, and these values are now provided as solutions to the wind farm simulation problem. So you also see there are interfaces for different kinds of wind turbines as well as configurations in this Dynamiks software. It's also user friendly. It's slightly simplified compared to how PyWake was. Even from the user documentation, you see that the number of pages are slightly less than what PyWake has. Also, it's a multi-fidelity program. In other words, when it's calculating for, let's say, wind in the wind farm, it doesn't follow just one method. It's possible for you to select multiple methods. For example, you can select multiple methods for the wake model. You can select multiple models for the wind, how the wind varies in terms of elevation or in terms of turbulence. You can have multiple phenomena being analyzed at the same time. So it's more dynamic than PyWake itself. And again, the values are in time series. Furthermore, extreme and fatigue loads of wind farms can be simulated. Changing inflow, turbulent control, validation of low fidelity models against high fidelity models. So you are able to carry out like a comparison between two approaches. The approach that was usually performed using PyWake and the approach being performed by Dynamiks, to know which one is best in the current circumstance. So this is a basic flow map when simulating with PyWake. So once you have your parameters for what you want to design for the wind farm, you take it to the site, you generate parameters for the site, you come back to your wind farm model, you generate the properties for the wind turbines, come back to the wind farm models, then select a model, engineering models or CFD runs for the behavior of the wind speed behind the wake as well as turbulence factors. And once that is done, it runs the analysis and your results come out as before: the power, the annual energy production, flow maps, and other information. So for the PyWake overview, still, when you have the site, you might have a wind rules that shows how the wind behaves in a particular location, the direction of the wind speed, the average wind speed, the maximum and the minimum. Everything comes up as these wind rules. which is what is used within the analysis. Then for the wind turbines, you have the characteristics of power for the wind turbine, so how the power varies along with wind speed, and also other parameters for the wind turbines themselves, which are defined. And furthermore, for the various engineering models, you see there are various models: wing deficit model, superposition model, rotor average model, different models that can be used for the wake and how the wind speed behaves after hitting an upstream wind turbine as it proceeds downstream. So these are some of the models when you elaborate on them in terms of imagery. So this is what some of them look like. Superposition model, this is what it looks like. And this is the rotor average model. Then the deflection model. So at every point in time, those models can be applied while using PyWake. But when it comes to Dynamiks, Dynamiks is a little different in the sense that Dynamiks is modular, is flexible, and is multi-fidelity. So you can see now the different hierarchy of how a design is done in Dynamiks. It's not as simplified as PyWake, although it is more user-friendly than PyWake. You can see here the different models. You have more models than we have for PyWake. So you can see the DWM. There are also other functionalities that will be provided for or developed further in the future. You have ellipses, low eddies, and simulation for wind behavior. So on that side you have mean wind speed method, you have the shear method, you have the turbulence field. So you see that it's not just only one method under the site. Then for the wind turbines, you have multiple types of wind turbines. You have the Hawk 2, the parallel runner, the actuator disc. So there are multiple wind turbines, which is more expanded than what you have for PyWake in the past. So you can see here when generating a model for Dynamiks that for the site, one method has been picked. So you are going for the mean wind speed. The wind turbine actuator disc has been picked. Then for the wind model, you can see that multiple at the same time are being picked, because you will not just use only one of the methods. As you saw from PyWake, for example, the deflection method works differently from the superposition method. So you need multiple of these models at the same time to be able to accurately predict the behavior of the wind behind an upstream turbine. So this is now the multi-fidelity at work. You can see here for the site, you have picked mean wind speed. You've also picked turbulence field for the Hawk 2 wind turbine or wind farm site, hyper simulation. Then for the wind turbine, still it's only one. Then the engineering models is still only the one approach that is being used. So you can now see the further expansion here. For the wind turbines, it's not only one approach, that not just the actuator disc that is being used. You are now using other types of wind turbines. Real world wind turbine configurations are being used for this analysis, which will also give you different kinds of results as opposed to just using a basic actuator disc, which may have different behavior when compared to an actual real world wind turbine. So this was a case study that was done for PyWake. So you can see the upstream turbines and the downstream turbines. You see the top row. Top row is 0, 1, bottom row is 2 and 3. And so because when you have an upstream turbine, it slows down the wind behind it, which is the wake. So for the upper row, which is 0 and 1, you have 9.7 megawatts, and the lower row is giving 9.3 megawatts. So you can see how the graph plots the various wind power that is coming out of each of these turbines for the top row and the bottom row. So this is now Dynamiks. So that's PyWake on the left, which is 0.02 seconds where the results come out. Dynamiks at 6.75 seconds. Remember that Dynamiks runs values in time series. So at 6.75 seconds, it provides us with power at the top row of 9.9 megawatts and the lower row of 9.3 megawatts. So you can see here. So another case, when Dynamiks was at 2.0 seconds, you can see although some of the wake behavior has been grayed out, showing all white, meaning that at this point in time the wind speed was much higher. It was a minimum of 10 meters per second. So probably the field had changed, and even the behavior of the wake behind the wind turbine had also changed, which is why the wind speed is above 10, because when there is mixing, there's a tendency for the wind speed, the wake, to actually increase in speed. Not all the time do you have reduction of wind speed at the wake, which is what this Dynamiks, which is how Dynamiks is a better option than PyWake, because it models it in real time, how it happens in real life, more than PyWake does. PyWake is more static, it just picks one model and follows that model all the way to the end. But Dynamiks allows for application of the multiple models, because there are some models that say that there is mixing of air speed behind the wake, meaning that once a vacuum has been created, once it passes the upstream wind turbine, there is air, there is wind that is rushing into that space, because that's diffusion, rushing into that space from the left, the right, the top, the bottom. Not just to assume that you have to wait for the whole wind speed to recover after a certain distance. So Dynamiks takes this into consideration. Next, you can see this drawing here, which shows us the white patches. It may look very insignificant, but those white patches are showing areas where you have 13 meters per second, which is much higher than the 10 meters per second we saw earlier from PyWake. So this is a dynamic wake meandering model. So you can see the light blue areas falling within the area of 11.56 meters per second, which is still higher than 10. Then the darker areas of blue is where you have the lower wind speed. Probably you have 8 meters per second, 1.4 meters per second. So you see that it's slightly different from the analysis being done by PyWake. So again, you can see here at 2.0, these are the results from PyWake, the amount of power that is being generated. Sorry, these are the values from Dynamiks, the amount of power being generated compared to what was done for PyWake. So it shows you the amount of power that is being generated. So once again, this is the performance of Dynamiks, it being a multi-fidelity program. So these are some parameters that you can actually study further to know how the Hawk tool works, the different parameters, the different wind turbine configurations under that module. So this is showing where some of these wind turbine systems, so this is showing where Hawk tool has been applied in different project locations. So you can see examples and applications of the Hawk tool model. So these are existing models from real world wind farms that have been applied in Dynamiks. So thank you for watching this video. This is Calculator Resources, where we create for better living.